All right, so in this video lesson, I am going to explain how, and I'm going to show everyone how to model a business problem or any business problem using function or by coming up with functions. And so before we can get started into any of the examples, I need to introduce and emphasize the one fundamental concept that anyone who is studying the business should have seen this in some of your, like, for example, business course or econ classes prior to entering into this class here. And here it's just an emphasize that anytime you're leading a business or anytime you're doing a business, these three fundamental concepts are always there and extremely sequentially connected with each other. Let's say you're a producer or you're about to make a business, then the first thing happens is you need to consider cost. Cost is, and in my brief definition here, that cost is just simply indicating how much is being spent to produce X units. So X here, you can see that X represents the quantity. So a lot of time in business, application cost depends on the quantity being produced. And think about the whole point of producing these quantities is that the quantities being eventually, once they are being produced, they will be sold away. And so usually in business, quantity right here, X to represent a quantity, but people also see this as quantity being produced and the same as being sold. So they are usually the same meanings. And bottom line here is that cost is a lot of time dependent on the quantity, on X, the quantity, on X units. And so once you have determined cost, how much cost that to produce X units and then eventually sell them away, then the next thing now is that we are going to sell them away. So it comes revenue. So revenue is defined to be the gross income after selling X units as at price say P dollars per unit. And so, and straight out from the definition, you can see that revenue is simply the price times the quantity. And so revenue equals quantity, how much or how many of those units you can sell, multiplied with the price. And so straight out of that, what you can see here is that revenue quantity is the X number of units multiplied with price P. And so this right here is perfectly an expression of a function. And so revenue can also, the amount of revenue that we making after selling X units can be regarded as a function R of X, depending on the quantity X units. And then, but keep in mind that, and anyone doing business are well aware that revenue is not truly your profit, not truly what you actually earn to support your life, because revenue here is only indicating the total you make after selling that many units away. But then profit here is the actual income earned after consider cost. And so straight out from that understanding, and in practice, and it makes sense that in reality, profits comes after we subtract. So in my screen right here, it's in what it says right here, so the way it is, profit equals revenue, take away the cost. So after you have sold all of your X units away, and ideally, let's say you have sold all of your X units that you have produced right there, then the revenue subtract away, take away the cost. That truly gives you how much profit you have earned. And so, staying closely with this rule right here, with this fundamental concept right here, where these three stages connected with each other sequentially like that, then let's bring that into a couple of examples. And so in any of my examples, I'm going to try to show you how things are being really close. I am going to show how we can work closely with the fundamental concept here. All right, so now let's look into one of our example here. So let's say the problem is simple. What matters is we're gonna have different kind of questions regarding this information. So starting out, pretend that yourself here is being an analyst, some kind of you're working in some kind of job that you're analyzing and coming up with a function for a business leader, a function to help their business grow. So here you're reading an article and it says, as of March 2019, Yellow Cab Chicago's rates amounted to $2.80 on entering the cab plus $1.65 for each mile. Now, I have to admit in the beginning that any of these, or in particular this example, is not truly reflecting what's going on with Yellow Cab Chicago, but it's intended for educational purpose only. And so these figures I'm showing in my examples are not exactly reflecting what's going on at Yellow Cab Chicago. However, the situation is what we can learn about. And so that's all the information we have. As of March 2019, Yellow Cab Chicago's rates amounted to $2.80 on entering the cab, and then plus $1.65 for each mile. So right from reading that information, we can start concerning about the first question being brought up here, and that produced one problem for us. Let's come up with the cost function. So I'm going to say find a function c of x that represents the cost of riding a yellow cab in Chicago for x miles. Let's say, think about customers, anyone who hop onto a yellow cab in Chicago and want to travel the 10 miles or want to travel 100 miles, what kind of cost are we expecting that they're going to have to pay? And being able to come up with this function, it helps any of the customers to understand that how much any one of them have to spend for getting the cost. Think in terms of the company. Once they know this function, then they eventually can use this information to find out how much they can make from their customers. And so this cost right here, once again, my bottom line here is the cost here is for the customer to spend out. So in the way how I see it, and the information is stating clearly right here, this information, the rates amounted to $2.80 on entering the cab. Such an important property right here, but it means for any customers, you always have to pay sort of like a base price. So there's a base price here being $2.80. So anyone, it's me, it's you, it's anyone who just, as long as you hop onto their car, their cab, you got to pay out of pocket immediately at $2.80, no matter how far you go. And so for that reason, this base price, this base cost right here, in formal term, we refer to this as, it's a cost, but now we refer to that as a fixed cost, because it's completely independent with how many miles the rider go. It's completely independent with how many miles that the customer is going to stay on the cab. And so after fixed cost, then there's the other cost that makes sense to come in. That's now the information said $1.65 per mile for each mile. So now this cost right here, it will become bigger as you travel or as you stay longer in the cab. So So now if you travel for X miles, then it makes sense that this cost right here is $1.65 for each mile multiplied with X miles. Basic math comes out. But so the understanding in this portion of the cost here is we regard to this as a variable cost. And so now, generalizing the idea together, so it looks like considering the overall cost. So adding the two terms here, now it gives us our final cost function, C of x right here, cost as a function depending on how many miles of each traveler, each rider stay in the cab is going to be 1.65 times x, the rate per mile times x miles plus the base pay for anyone, $2.80. But that now we finish coming up with our cost function that represents the cost out of pocket for any customer, any consumer, any rider. And so then the same example, once we come up with the cost function, let's say now the company should be able to tell. That's why I'm bringing up the next question here. What about let's find the cost for any customer who are riding for 31 miles. So the advantage and the whole purpose, not only here in this example, not only here in this problem about the Chicago cab, about the yellow cab Chicago, but in any problem, once you have come up with cost and knowing what cost function, and that's the whole point of we're modeling. So once we model, we came up with a function to model cost right here, then we can use that to predict and to exactly come out with any cost at any variable miles input right here. And so here in this particular problem, I'm looking for finding the cost of riding for 31 miles. So now that is the cost for riding 31 miles is exactly the cost function substituting in 31, or in other words, it's C at 31. So now the cost function we came up with 1.65 multiplied with the inputs 31 miles plus 2.8. Calculation comes out being, so for any customer who travel on any of the yellow cab Chicago, and let's say traveling for 31 miles, the customer is going to have to pay $53.95. And so this is the kind of information useful for both customers riding their cabs and useful for their company, so that they can know, hey, say traveling 31 miles, then anyone's going to have to pay that much. So think about if they have 10 customers a day right here, and each one of them are traveling 31 miles, let's say from an airport to a home that, airport is being 31 miles away from home. This is how much they make, the company, the yellow cab company of Chicago make out of each customer. But that is how we're done with answering this question. And so in the same example, again, same useful information. Let's look at a different question. So find the cost of the 4th mile. So be careful with the wording a little bit here, but it says the 4th mile. So the intention of saying the 4th mile is that the 4th mile, as in my explanation here, the 4th mile is really the next mile after a rider has ridden for 3 miles. And so take a moment to think of what I'm writing here, to think of what I'm explaining here. The 4th mile, find the cost of the 4th mile, but the 4th mile in this problem is the next mile after a rider has ridden for 3 miles. So that means that after you have, or anyone have ridden for 3 miles, then the next mile truly is, it's just 1 mile away from 1 mile additional after 3 miles. And so in other words, we just need to measure in this way right here. That cost there simply comes out as just, all we need is to measure how much. If you would ride for 4 miles, how much that would be as a difference with riding 3 miles. And so bringing that into our functional concept right here, what we're looking for now is that the difference between C at 4 minus C at 3. And so now it going to becomes, so I'm going to substitute C at 4 into the function and getting 1.65 times 4 plus 2.8. And that is the cost for really traveling 4 miles, even though we were not really traveling, but we just want to find out how much that change would be. And so, and now we minus how much the cost is after riding 3 miles. And so that would be same function again, but we're evaluating at 3. So 1.65 multiplied with 3 plus 2.8. And calculation turns out to be 1.65. And so this is how much cost, additional cost being paid extra if after traveling for 3 miles you will travel 1 more mile. So the cost being brought in for traveling the next mile after riding 3 miles is going to be $1.65. And so now, in case anybody concerned about why am I doing such a complicated math problem to answer only a simple thing, because everybody knows right from the beginning, everybody is aware that, hey, the cab company here is charging a fixed rate being $1.65. So if you have already traveled 3 miles and then traveling for the next mile, of course you only bring in another $1.65. Why doing so much math? Why doing so much fancy work, like say C of 4 and minus C of 3, and particularly bringing in that explanation? But that was the point, because the idea is that your function now currently, the situation we're looking at here, Yellow Cab of Chicago is setting up a simple situation where the rate is fixed. Now I'm talking about the rate being fixed, but I'm not saying that this is the fixed cost. So don't mix up the two concepts here. But since the rate here is being fixed, so it's making life easy for us. But as your career, as your business career is becoming more advanced, the rate here is never going to be fixed. And so in that case, once you come up with your model, your modeling function, then this is the formal work right there to lay down and find out how much additional cost being brought in when you travel for 1 more additional mile. And so in that way, if you're looking at this kind of problem, the overall idea here, it's not particularly aimed for this problem, but it's starting to make some connection. But what we have found here is indeed the marginal cost. And like I said, it's not the main intention of this example yet, because we're just beginning in studying in this quarter. So all these concepts will be introduced later in the quarter. But right now it's an early start to have a look at. So what we have found here is nothing but just the marginal cost that you have seen this term in any of your econ course or any of your formal business class. And so now, same example, another question can be brought up. So this question now is really similar to the earlier question we have done here, but find the cost of the 7th mile. And so at this point, after answering question C, the earlier question, then we are having a little bit of experience now. this question is intended to look for how much that change between riding the cab for 7 miles and considering that difference with riding the cab for 6 miles. And so, and in a similar explanation, what I'm looking here is that the cost of the 7th mile really is just how much cost the cost of the next mile after you have ridden for 6 miles. And so that change here, C7 minus C of 6, is going to be, and once again coming out from your calculation. First, let me write down the calculation. Same function. So 1.65 multiplied with input 7 plus 2.8. I'm grouping them in a pair of brackets, and I'm subtracting because we're taking the difference. And then the same function again evaluated at 6. So 1.65 times 6 plus 2.8. So each of these two values, whatever comes out of the calculation, the subtraction finally comes out, the calculation finally comes out to 1.65 again. And the reason I'm repeating this kind of question on a different thing, on a different value right here, is so that I can remind you what I said earlier, is that in this problem, since the cab company set up a simple fixed rate of riding their cab, so that's why, if you keep doing marginal, and by the way, this is a marginal problem again, another marginal cost problem. This is the marginal cost. And so much work here, but it perfectly makes sense since the cab company set up a simple fixed rate right here. So no matter, if you bring in if you have ridden for 6 miles and bringing in the next mile, the cost there is still $1.65. If you're looking for the cost of riding the 10th mile, it's still the same, $1.65. So it looks like the little bit of experience here that we've learned, the function we came up with, concluding our examples here, the function we came up with, C of x equals $1.65 times x, that's fixed, that's variable cost, plus 2.8, the fixed cost. This function here, it's a little early to introduce as well, but you have seen in algebra the kind of setup in this function is regarded as a linear function. Linear function. And so marginal cost, when your cost function is a linear function, then marginal cost is always the same as that slope value. So this is in the concept of being a linear function. This is slope. And in our business application, slope equals the marginal cost. But like I said, right now what I wrote down is not the big generality out there. The generality out there is going to be introduced later in your later course. But since our function right now, our cost function is being a linear function, then the marginal cost truly is the slope of your linear function. And so now we are ready for a different example. The big intention of this problem is to emphasize that all the three fundamental concepts of cost, then revenue, then finding profits are always extremely sequential. You cannot find the profits without knowing the cost and the revenue. And so in this example, let's say the information says the parent company produces and sells P phones. So, think about a scenario that we got Apple companies that making iPhones. Now, parent company produces and sells P phones. Their production costs are $340,000 plus $140 for each P phone they produce. So it looks like right here in this first part of the sentence here, then this is indicating, this is sort of like a description of what their cost is going to have to be. And so now, but the next statement in the same sentence here say, but they can sell the P phones for $280 each. this is, in other words, the price of right here for each P phone. And so now we have price. So that's all the information we have. But now immediately we can, this is what we can do with that information. The first question here, let's find a function P of Q. Now, I just want to reinforce the fact that x is not the only x represent quantity a lot of time, but also Q is another symbol or another variable for quantity. So throughout a lot of our examples here, I'm going to be using interchangeably between these two variables named right here to represent quantity. So sometimes you see a problem indicating x units, that's quantity. Sometimes you're seeing a problem using Q for Q units, that's another variable for quantity. But so once again, back to the question, I want to find a function P of Q that represents the profit made at Q units. So you can see that this question immediately, right out of the box, the question, nowhere in the question is asking for find the cost. But you have to understand that sequentially, we need to have the cost before we can decide how big the profits that we earn. And so, and that is the reason why now looking back into this information right here, the problem did provide for us some information regarding how much P-phone had to pay to produce their products right here. So their production costs are 340,000 plus 140 for each P-phone they produce. So now let's figure out that, let's say that 340,000 right there, the way how it was described is that they always have to pay for that amount right there. And so we already have recognized that we had a fixed cost being $340,000. That could be paying for the factory, paying for the facilities, electricities to run their companies, paying for labors, whatsoever. Actually, labor should not be the part of fixed cost right here. It could be the part of the variable cost. And then as I'm about to get there, the variable cost for this problem is $140. They got to spend $140 on, think about, we got to pay for parts, like this different little, those are chips, those are little circuits that they got to buy, and the little screens to put on their P phones. You know how those smartphones in these days, they got a lot of little components in there. So all of those components come together being part of that variable cost, because the variable cost here is that the cost that come out on each unit. So here, this is $140 per or each. It's a little awkward to have that slash there, but $140 each. So that means our cost function here, and like I said again, even though the question did not specifically ask for that, but it's our responsibility as being an analyst. We got to know how much cost we spent before we can find out how much profits that company made. And so cost here, now you can see that $140 each phone. So producing Q phones, Q units of phones, QP phones, then we're going, well, simple enough, that cost on each phone multiplied with Q. We got 140 Q. But then though that's variable cost right there. That variable cost is not enough. The company also paid a fixed amount of 340,000. So considering, we always going to need to considering the two types of cost together. There's fixed cost and variable cost. So now, but at least what we have come up here is our cost function. So cost functions, after cost function, but we're going to need to look for one more component. After we produced Q units, and determine how much cost we have to pay for making those Q units, then selling them away, that brings into revenue. And to remind everybody again, revenue is price times the quantity. And so in this case, the information, let's get back to the information of the problem here. The information said Pear Company can sell their P phones for $280 each. $280 each, that's the price. Simple. And we're going to multiply with Q units. And so now right out from that, we have a revenue function. And once again, realize that revenue function was not particularly asked in the problem, but it's our responsibility as an analyst is to find out all these costs, then revenue, to figure out how much profits the company can bring in for themselves. So R of Q equals 280 Q. So we have now an R of Q. So let's put check mark here. On the checklist, we found a cost. We now had a generalization for revenue. The next and the actual important step, what's being asked for now, is here. So profit is always rule of thumb. Revenue that we've sold, that total gross income that we've made, subtract the cost. And so in this situation here, what you're looking at now is the revenues being 280 Q as a function in terms of Q, minus, I highly recommend, and it's always the best practice, to put because now we're about to subtract a function from another function. We're subtracting two functions from each other. And this function C of Q that we're doing here has two terms. And so I highly recommend that we put the function being subtracted in a parentheses so that some sign change can be cautiously done later on. So 140 Q plus 340,000. So now we're looking at, so this is how we generally express our profits. But with your math skill currently, you can go ahead and distribute a negative sign and change the term and combine like terms. So what I'm having now is that we have 280 Q minus 140 Q and minus, that's why, like I said, I highly recommend to put your beginning functions in parentheses. Then the subtraction sign can cause some sign change. And by the way, I had a typo here. It's 140 Q and then minus 340,000. And then having these two terms or being like terms, I can go ahead and combine my like terms and reduce my expression down to 140 Q positive 140 Q minus 340,000. But now at this point, this is my profit function. And profit function, I should have used the functional notation capital Q, capital P of Q. And that is, and truly at this point, this is our profit function. So in the same example, the next question now being brought up is that, and of course after we found the profits function, the general profits function. So now the example here is asking how much profit is made when Pear Company produced and sold 200 P phones. So you can see that 200 here in our functional understanding, it is the value we're going to assign for the variable Q. And to remind everybody again that your profits function generally found to be at any production quantity right here, then we're looking at 140 multiplied with Q minus 340,000. And so now this question of ours in particular is nothing but find the functions p at, find the value of the function p at 200. And that is just now a matter of substituting in 200 into your function. So 140 times 200 and subtracting 340, actually 340,000. So calculation comes out 270, actually 27,660. And that is how much profit they have made for selling 200 P phones. And so now, at the end of two examples, let's summarize what we have done and re-emphasize the concept that we have learned through the examples. But so first thing, once again, anytime you're opening a business or leading a business, first thing we have to always consider is the cost, how much you spend to produce some X units, and that's where we call that famously the cost function, capital C of X. But then we've learned through the example further that cost now can always be the total of two different components. There is always a variable cost. So inside of your general cost, there's always a variable cost and the fixed cost that we have learned throughout our examples. And once you found out your cost right there and come up with a modeling function C of X, then it's time to figure out or to model the revenue. And once again, you have seen this definition earlier. It's the gross income after selling X units at price P per unit, P dollars per unit. And as a function notation, it's R, capital R of X. And revenue, the concept is here quantity times price. And revenue as a final function is always quantity X times P right here. Then it comes to profits. So the actual incomes earned consider cost, and then we call that function capital P of X. And we have learned that profits equals revenue minus cost. So function in a functional look right here, then it's P of X equals R of X minus C of X. So mathematically, it's always your revenue function subtract away your cost function, and that gives you your capital P profit function. Now, it did not happen in our example yet, but if you're looking at our example that we just finished earlier, so back into our final answer of the example we just finished, the profits we've earned at selling 200 units were 27,660. Now, there could be time. I'm not saying that we don't want that to happen, but there could be time when you're making a mistake and your profit turns out, whatever that quantity that you're selling, your profit turns out being zero. It could happen. So anytime your profit turns out being a zero, that means the same as revenue equals with cost. Then in that case, a special term, this is where we call that break even. And so sometimes, and just right out from that, saying profits equals zero or a break even point right here, it also means the same as the difference between revenue and cost is a zero difference. Okay, so these are the same right here. Now, sadly, in this video lesson, I don't have an example for having a break even, but it will come in some other video. So back in our general understanding right here, so just like how I said, then break even will happen when your profits equals 0 or revenue just not getting any better than cost. So revenue equals cost. Another concept that I could have also mentioned, but I wanted to wait until now, is that your final answer in the example we finished earlier was truly a positive sign answer, a positive profit. So being positive profit is a good thing because that means you truly are earning. But there could be times, it does happen sometimes, even though not too oftenly, because we don't want that to happen oftenly. It's bad for a business. But there could be time that your profits calculations, after considering revenue subtract cost, profit comes out being negative sometimes. Okay, or in other ways, being less than 0 value, negative profit. Okay, it could be, like I said again, it could be another mistake in calculation. Now, successful business strategy is gonna the whole aim is to aim as getting the positive profits and to the point of even more and more positive. But unsuccessful or failure in business plan is to when you end up with a break even or the profit being a negative profit. And negative profit is when that is when the term profits turn into loss. Okay, loss is actually the same as negative profit right there. Or another way of seeing that is the worst thing ever happen is when the revenue you sold is even less than the cost that you have spent to produce the items. And so that's what it is. Profits become loss. Different names, different way of calling it. When your profits is a negative sign value or the revenue is less than the cost.